In 1978, visiting U.S. National Security Advisor Zbigniew Brzezinski presented China a goodwill gift, 1 gram of Apollo 17's moon rock. Half of the historic sample was given to a team led by Chinese scientist Ouyang Ziyuan. This tiny flake of lunar material inspired him, and in the following years, he proposed the Chang'e project, China's lunar exploration program. If everything goes well, in a month's time, we're going to have some new moon rocks collected by the Chang'e-5 probe. It will add to the 382 kilograms of samples that US and Soviet space missions brought back 48 years ago. Chang'e-5 has been the most complex space mission undertaken by China so far. It is composed of 4 parts: the orbiter, lander, ascender, and Earth re-entry module. The lander and the ascender form the combination that will touch down on the lunar surface to collect samples. It will collect 2 kilograms of lunar sample, shoveling some surface material, and also drilling a 2-meter deep hole and extracting the soil from inside it, which will act like an archive of the moon, with the bottom recording information from 1 billion years ago and the top more closely reflecting the present day. The work will be completed within 1 lunar day, or 14 days on Earth, so that the probe can avoid extreme overnight temperatures that could damage the robot. Once the samples are secured, the ascender will blast off to transfer the moon samples to the re-entering capsule waiting in lunar orbit, which will then carry them back to Earth. In previous missions, the ascender would make the journey all the way back itself, but this innovation allows it to save fuel and gives it space to carry more samples. Well, 2 kilograms of lunar soil can fill 2 coffee jars like this. So why is it useful to collect all this dust and debris? First, it can help us better determine the age of the moon and other planets based on a method called crater counting. Yes, you're right. Just count how many craters of various sizes or help scientists estimate how old a planet's surface is. This method can work based on the assumption that a newer surface should have fewer impact craters, while more heavily cratered terrain would generally be older. But you may notice the weakness here. Counting craters simply allows us to calculate relative ages. For example, we can figure out that the heavily cratered lunar highlands are older than the dark lava plains, but scientists can measure the actual age in years. And that's why we need lunar samples, because they can be precisely dated back on Earth using radiometric technology, so that we can use the date of samples to calibrate the results from crater counting. But so far, all the samples brought back by the Luna and Apollo missions come from regions up to 3 billion years old, but we don't have any benchmark for more recent periods, and that gap could be filled by Chang'e-5 new samples, because it will touch down in the northern part of the Oceanus Procellarum, the vast lava plains that are believed to be as young as only 1 billion years old. In addition to that, we should be able to better understand the moon's volcanic activity. Previous samples suggest it stopped around 3 billion years ago, but Chang'e-5 sample, which may contain volcanic lava formed just 1 billion years ago, could reveal that the moon was still active for a longer time than expected. Further, scientists hope the samples will tell us what fueled this thermal activity for so long. Lunar soil also holds the secrets of the sun. Unlike Earth with its magnetic fields as protective shield, the moon has been exposed to the bombardment of solar wind, so particles injected from the sun throughout different time periods will be buried in the different layers of lunar soil. That will give us the chance to learn about the changes to the sun through this history. And don't forget, our research on lunar samples today will be a fundamental for the potential lunar base in the future. For example, we have already found lunar soil and rocks contain hydrogen, which is left behind on the surface by the solar wind, and also a type of mineral called ilmenite. If you put those two things together to react, you can produce water. So we're one step closer to being able to function in space without needing basic resources from Earth.